Did you know that every time you type thank you to an AI chatbot, you're wasting energy? No, seriously, a harmless, polite message, 2 words, 10 letters, it triggers the same exact massive computation pipeline as asking it to write you an essay or solve a complex problem. Because here's the thing, AI doesn't know you're just being nice. It doesn't distinguish between thanks and write me a business plan. It sees input, and input means boost up the GPUs, spin up the coding fans, start running billions of mathematical operations, and burn electricity. One thank you, harmless. A million of them happen every hour across the world. That's a power bill the size of a small city. And this tiny ridiculous example is your first clue into something way bigger. The digital world looks clean, invisible, weightless, but underneath, there's an engine consuming more power than entire nations. This is the internet's real energy crisis. Let me walk you through what happens when you send any message to an AI model. Not just a complicated prompt, not just a question, even your polite little thank you, it goes through the same pipeline. Step 1, your phone to your Wi-Fi router. You hit send, your message travels through radio waves to your Wi-Fi router. Step 2, routers to your internet provider. The router passes your message to your internet service provider, Airtel, Geo, Comcast, whatever you got. Step 3, internet service provider to the internet backbone. Now your message jumps into fiber optic cables underground, under the streets, under oceans. Step 4, backbone to a cloud data center. Your text gets routed to whichever cloud region, AWS, Azure, Oracle Cloud, Google Cloud can handle the load fastest. Step 5, load balancer to GPU cluster. A load balancer looks around and asks which machine has enough space to run this model right now. It assigns your message to a GPU cluster, thousands of chips wired together. Step 6, GPU interface. This is where it gets expensive. This is the real energy burn. Billions of mathematical operations fire off in milliseconds, electricity surges through the system, cooling systems kick into high gear, megawatts turn into sentences. Step 7, the reply comes back. Model to cloud network, to backbone, to internet service providers, to router, to your phone. All of that infrastructure, all of that coordination, all of that power for thanks is the hidden cost of digital intelligence. And honestly, it's just the beginning. We treat the internet like it's made of nothing. Swipes, taps, streams, all just floating around in some magical cloud somewhere. But the cloud isn't virtual. It's a physical machine, a massive one, the size of multiple city blocks in some cases. It heats up. It needs constant cooling. It burns electricity 24 hours a day. It hums with the sound of thousands of fans working overtime. Our digital convenience, all of it, rests on this massive physical infrastructure that we never see, but we always depend on it. Okay, so let's talk some numbers. Real numbers. In 2024, global data centers consumed 415 terawatt-hours of electricity. That's more than the entire United Kingdom uses in a year, just for data centers. In the US, data centers currently use 4 to 5% of the nation's total electricity. And according to International Energy Agency's projections by 2030, that number could hit 945 terawatt-hours globally. That's nearly double what we're using today. Want to know what's really wild? In Ireland, data centers use 21% of the entire nation's electricity. 21%! 1/5 of the entire country's power, just to keep servers running. We thought the digital world was efficient, clean. The future, turns out it's just hungry. Really hungry. So what's causing this massive surge? There's 3 things. First, streaming. 4K, 8K, HDR video, every single pixel costs power, both in your home when you're watching it and in the massive server farms hosting it. Second, cloud computing. We stopped running apps locally on our devices. Everything lives in the cloud now, which means everything requires server power. Third, artificial intelligence. Training a single large AI model can consume as much electricity as a small town uses in weeks. And interface, actually running the model like when you chat with ChatGPT. That's happening billions of times every single day. AI is incredible. It's revolutionary. It's also an energy black hole. Here's what's starting to happen when too many many data center clusters in one area, the local power grid started getting stressed. Ireland had to literally pause new data centers approvals because their grid couldn't handle more. Parts of Virginia, which had one of the highest concentrations of data centers in the world, are hitting power limits. Singapore had a moratorium on new data centers for years. Oregon and Arizona are now struggling with grid strain. We keep demanding AI, more cloud storage, more streaming, more everything. But the power grid, it wasn't built for the level of digital consumption. Its physical limit in a world that thinks everything is just digital magic. So here's the thing. The way forward isn't just building more power plants. It's building more intelligence into how we use power we already have. Not add more servers, but make the servers we have talk to each other better. Not build bigger data centers, but coordinate global workloads so we're not duplicating efforts and wasting energy. We need smarter routing, smarter cooling, smarter decision making about how computation happens, where and when. We need systems that orchestrate computation like a conductor leading an orchestra, timing everything perfectly, syncing it all up, optimizing constantly, reducing waste everywhere. This is what the future has to look like, not just automation, orchestration. Now let's take procurement for an example. It's one of the most energy wasteful processes in the global business. Manual follow-ups, slow decisions, thousands of emails being sent back and forth, each one of them triggering the same massive AI and computing infrastructure we just described. At ProCube, we're building AI agents that don't just automate those repetitive tasks, they orchestrate entire systems. So instead of burning energy on endless back and forth communication, the whole process becomes coordinated, efficient, and intelligent. Because the future isn't about running machines harder, it's about running them smarter. The internet feels instant, doesn't it? But it's not. Every click is a spark of electricity. Every search is a surge of power. Every casual thank you to a chatbot is a computation running through billions of transistors. We built the world that looks completely digital from the outside, but it's painfully, unavoidably physical underneath. And if we want AI everywhere, if we want automation, if we want cloud to keep expanding, if we want the future we keep on talking about, we just can't chase more power. We need to chase more efficiency, intelligence, orchestration, because the next big breakthrough in technology won't be the newer, bigger AI model. It'll be a smarter way to use the energy we already have. The internet doesn't run on magic, it runs on megawatts. And the crisis isn't coming someday in the future. It's already here, right now, every time you hit send.